Bill Nye the Science Guy. Bill Nye.
Consider the following.
Newton's first law of motion is the law of inertia. It states that an object will keep moving infinitely unless acted upon by another unbalanced force like friction. Also, if an object is at rest, it will stay at rest unless again acted upon by an unbalanced force, like someone kicking a soccer ball. In our example, the tennis ball remains stationary and in place until Alex hit it. This is one instance of Newton's first law of motion in action. The other is when the ball stops. Newton's first law states that any object will keep on moving indefinitely unless an unbalanced force is acted upon it. If the ball was in a vacuum, it would keep moving forever. However, air resistance, gravity, and friction bring it to a stop. Newton's second law of motion is the law that explains how mass, force, and acceleration relate to each other. For example, it would require less force to push a box with less mass and to make it accelerate than a box with more mass. In our example of Newton's second law of motion, we push two objects of different masses using the same force. This shows the second law of motion because the object with a heavier mass took longer to accelerate. In the second law, another variable would be force because the more force, the more acceleration. However, we were able to isolate each variable by using the same force and having a set and defined difference in the mass of the objects. Newton's third law of motion states that for every action there is an equal and opposite reaction. For example, when you let go of a balloon filled with air, it will let air out in one direction, the action, while it will fly away in the other direction, the reaction.
In our final showcase of Newton's laws, we dropped the ball, which bounced back up to demonstrate the action-reaction of the third law. The ball hits the racket, which is the action, and the ground pushes it back up, causing the ball to bounce into the air. This is the reaction.